example 1 in 2.2 for Math 20-1 is where we look at how having a point on the terminal arm can really guide us as to the value of sine theta, cos theta, and tan theta. The biggest thing that I want to stress in a question like this is at no point do you need to calculate theta. And so many students will remember some of what they did in 10-1 or 10C, whatever, and they'll use inverse tan in this case to find theta, and that's valid, but it's never going to be the exact. And as soon as you see this exact trigonometric ratios, it means that you would have to use a number like root 2 instead of 1.41 with all the decimals attached. This is exact, whereas the decimal we call approximate. And then the level of accuracy we have depends on how many decimal places you take it to. So when you see exact, you need to think my answer is very likely to have some kind of a radical in it. All right, so it says that the point -8, 15 lies on the terminal arm. Now I'd like to identify right away that lets me know that x is -8 and y is equal to 15. That's what coordinates really tell us, right? The x is first and the y is second. It's that ordered pair. Now, when we look at our, drawing the angle, because x is negative and y is positive, we have to be in quadrant 2. I am not worried about drawing this to scale, but I am going to try to draw it at least, kind of reasonably close. And I'm going to put -8 for my x and 15 for my y. And then there's a nice right angle within that triangle. Now, what a lot of students misunderstand is that in this question, that arc right there is theta. The angle within the triangle is actually the reference angle for this question. Now, truthfully, it doesn't matter, because what we really need to identify in this question is that if we have x and we have y, we can determine what r is. And I'll label r in my diagram right here. It is the hypotenuse in that right angle triangle. So r is going to be equal to the square root. I'll put the equation in. It's x squared plus y squared. A pretty common mistake here is how students will deal with that -8. This is the square root of -8 in a bracket squared plus 15 squared. You need to make sure that you can do this on your calculator. This would yield the square root. -8 squared is 64. 15 squared is 225. So r is equal to the square root of 289. And if you use your calculator, now this is why we do chapter 5 in Math 20, is that you will run into questions where you have to simplify that radical. But at least to begin with, they do us a bit of a favor because that is a perfect square, the 289. And I get that r is equal to 17. Now, I'm just going to kind of cross this out and put a 17 there. But I'm also going to summarize it in that location. So now what we know is that r is 17, x is -8, and y is 15. And the reason why that's so useful is that we have 3 equations for sine, cos, and tan. I'm going to say that sine theta is equal to y over r. So for this question, sine theta is equal to, so my y value is 15, my r value is 17, so the sine of theta is 15/17. That's y over r. The cos of theta, which was x over r, in this particular question, I wrote sine again, whoops, that tells us that the cos of theta is going to be equal to the x, which is -8, divided by the r, which is 17. The last trig ratio then is tan theta. Tan theta is equal to y over x. So for this particular angle that contains the point -8, 15, the tan of theta is going to be 15 over -8. That's y over x. Now, you could clean up 15 over -8. It actually works out to a decimal, 925. I might be off on that. But typically what I like talking about at this point is you could write this fraction as what I did right there, so 15 over -8, or you could write it as -15 over 8, or what some students will do is they'll write it as -15/8. And a lot of students are frustrated that there's 3 different ways of writing the same number. Personally, I almost always write it like this, unless for some reason I like to see that negative in the denominator. I like having that negative in the numerator because I read it first, but all 3 of those fractions are equivalent to each other. So some important stuff in this question is that the point on the terminal arm allowed me to identify x and y, which I then solved for r, and then I wrote out the value of sine theta, cos theta, and tan theta. I really can't stress enough that we don't know what theta is. And at no point in this question do we need to know what theta is, because we can use the ratios to relate x, y, and r to the value of sine theta, cos theta, and tan theta.